be better served if someone in the class that's not dyslexic about the Excel arrows can drive for us. So let's take a look at number 1, and then we'll find a driver here. So you may have looked at it a little bit. You may have some of this information available or started on. That's great. But what we've got here is an appointment. So we have a doctor, and the doctor has appointments, and that's really what we're concerned about. So they have a list of attributes here for us, and they want us to create a dependency diagram, and that's the list of cells where we are just listing all of the different field names. So we have all of these different data columns, data points that we want to list. And we just want to do this dependency diagram. Chris is getting disconnected. I don't know if it's letting him back in or if I'm having to admit him each time. All right, so we need a driver. I'm going to stop sharing. Maybe here. And find the solution. Getting there, getting there. So I can start. There's just messages everywhere and things just flashing around at me. A little too early this morning. I'll share my screen. I'm going to start, but then I'm going to ask somebody else to take over when it comes to join the little arrows. So in Excel, if I want to create a new spreadsheet for this one, we're going to have all of these data points. And so we know just from looking at let's see. I can't tell. William, I can't tell if it's letting you join or not. You guys might just have to watch the video if you keep getting disconnected. We've got to have our class. Okay, so whenever we're looking at this diagram, first of all, we can start, if we want to draw this dependency chart, we've seen that we start with our keys. So for an appointment, they're saying that we're going to have this pnom is our key. So I'm just going to click in a cell here, and just the picture I'm looking at has it kind of a burgundy color. I'll just make our key here orange. And then this is going to be our APP nom. And notice in the diagram here, they have a space there. And I don't know, I guess there's an underscore. Let's see, there's an underscore. And then we want to underline it to show that it's a key. So there's our first data element that we have on our appointment. Now, looking at our appointment, the next thing we have is the employee ID of the doctor that did this appointment. And then we have the appointment date and the appointment time. and the patient ID. The name, phone, street, and once we get all of these data elements in here, we can copy them and move them around pretty easy. It's tempting at this point to say, well, and all those other data elements. But remember, we're at the point in our design where each individual data element is really important, and we have to keep track of them all. Now, if I want to resize, I'll fix everything, kind of reformat my spreadsheet so that my columns fit these different data element names. And then I can make them a color. Let's do a background color here on them. What color do you want to make them? Blue? There we go. And then the other, sorry, people just keep getting kicked out of our, well, actually it's all William. I'm removing him, removing. This machine must be doing something weird. We've got our appointment data element then here with this kind of first normal form that they gave to us. So now we need to be concerned about this doctor entity. So I'm going to add its data elements to our spreadsheet here. So our primary key is the doc emp ID. And then we've prefixed everything with doc underscore here for our doctor table. We have the first name and the last name and the cell phone. It's our doc ID that's the key, the primary key. So I'll underline it and I'll make it our color that we made our key. And then I'll make all of the other data elements blue. And then I'll do the format. Make them a little bit different in size. Now, if we were to list this in first normal form, we could really easily see the appointment or the patient's address all as one column. So we know that that cycle has already occurred here where somebody's gone in and said, wait, this is an element that can be broken further down. So we have to break it further down into all of the lowest level elements. So we've already broken it down into the street, city, state, and zip code. That's good. That was all the things that we needed. Now, as we look at this, and if we started to draw some arrows here between what kind of things are dependent upon all of our key fields, as we look at the doctor ID, is it dependent upon our appointment number? It is in this case. Okay, here's where I've got to have somebody else start driving. I'm going to disconnect because my failure at arrows is extreme. So embarrassing. Okay, who can drive? Chelsea, drive for it. Okay, you're so sweet. I'm going to put this over here. She's already got a lot. I'm gonna have to working on it over the weekend. You're so good. Confident in what I had completed, so to turn it in. Well, let's back up a little bit and start with the big giant one across the top, because she's got it broken down perfectly. We want to start out with this one though and take advantage of her awesomeness with our arrow making ability. And going across that appointment number, that appointment entity, as we look at it, we could basically say that that appointment number key field controls all of the different fields. So we could start out and draw an arrow pointing into our appointment number, and then have arrows going into all of the other fields. Can you do that with just a copy and paste? Yes. Show us how, because my abilities are limited. Now, as we're creating these dependency arrows showing that everything on this entity is dependent upon this appointment number, going across the top, we're just kind of saying we're going to account for every single attribute in this entity. It's sort of in first normal form because it doesn't have those grouped elements, and it doesn't have any repeating elements. But as we look at our dependencies, we're going to see that every single column is dependent upon that appointment number. But as we go across, there are some other things that might be a little bit different. For example, when I get to the patient ID, and let's draw some arrows at the bottom, and we'll come back in and do all those ones across the top. But if we look at the patient ID and we look at that app name, the appointment name, is that, we have to kind of make some assumptions here. Is that our patient's name? So is that patient name really dependent upon the appointment, or is it dependent upon the patient's ID? The patient ID. So that dependency we can show across the bottom. So let's show that we have this transitive dependency where the patient information, being the app name, their phone, street, city, state, zip, and status, all of those data elements have a dependency on that patient ID. They're dependent upon that column.
That is the flat one with no arrows, right?
On this one, they want the arrows for this transitive dependency, and we don't have any of those types that we've identified yet. So our arrows going across the top, we can kind of know that we're going to have those because we're basically tying every single data element to this. And when you guys are working on that other activity where you have to drag the colored squares up in there to resolve the dependencies, the one that's kind of tedious, they want you to just use the remaining data elements that haven't already been used. And you'll know what I mean if you've been fighting with that one. So great job. We're getting our dependencies here to show that all of these are not really dependent on the appointment, because a patient could have many appointments, right? They're all dependent on this patient ID.
The app status, can you go in there too, or that comes in somewhere else, right?
Yeah, I think they want to leave it out of this because the status is really dependent upon the appointment itself. Of course, we would have to maybe find some more information. Now, if we look at the document information, we could say that, or I'm sorry, the doctor information, we've already kind of pulled it out. I did on my own without even having that ability yet. So let's show that dependency in this example. That our doctor, first name, last name, and cell phone is all dependent upon that doctor's employee ID. Now, as the dependencies get drawn on there, I'm going to continue analyzing. We've basically decided that the appointment date, the appointment time, and the appointment status at this point are only dependent upon the appointment. That's the only connection we're going to see for them. But we're seeing these other dependencies in some of our other data elements. When we analyze the app name, we see that belongs to the patient. When we analyze the doctor's first name and last name, we see that belongs to the doctor. So we're identifying these dependencies. It's kind of sorting our elements into the right entities, right? And we can do that by saying that they're dependent upon that key field. Now, a couple of other dependencies that we have that aren't quite as noticeable have to do with the addressing. And if we look at the address, we could say that, let me see if I can get this the way they want it. They just kind of have it hanging off into Never Never Land. The zip code, the city and state are dependent upon the zip code.
Can we zoom in some way? I really can't see what's happening.
Sure. Thank you, Chelsea. So we've got all these dependencies that we can see right away, that the doctor's name is part of the doctor's information, and the appointment patient information belongs to the patient. But this is a dependency that's kind of something that occurs in all addresses. So we can put it on our dependency table. The city and state are dependent on the zip. How's everybody doing? Good, good, good. Let's resolve some dependencies. First of all, the first, they're talking about all sorts of wonderful things here. The first dependency that we see is kind of embedded, and that's the doctor's information. So let's pull that out, and Chelsea already has it here. So we're saying that our doctor's employee ID, first name, last name, and cell phone would create a doctor entity. And then here's our schema information for that doctor entity. Again, if you copy and paste from that first one,
So we need to include all the like app stuff up at the top too.
do I?
That app or all like the app attributes are dependent on that app number. Do we need to include that, or is it good the way that it is?
They want you to include it.
Okay.
I'm implying it. That we have implied that everything across the top is related to both of those keys. Now, we pulled that doctor information out because if you notice, it was embedded within our original appointment entity. And we also see that our patient information is embedded. So if we pull our patient information out, we're going to see our patient ID, name, phone, street, city, state, and zip. So we'll be retaining that separate relationship with that zip in city and state in our patient entity. And then Chelsea's ahead of us, so she already has the remaining entities placed in the appointment.
I think the only thing that I was confused on is if you needed to separate out the location, the city, state, and zip, because I think I read somewhere in the book that it's like you almost have to be careful doing that because breaking down the data too much will cause redundancies. So I wasn't sure if that was something to do or not, and that's why I didn't turn it in. So you do need to separate it down that much.
Well, we have to decide because it is a design decision that we have to make to see.
So you would have accepted it
either way.
Okay.
And what's important here, this one thing that's important here is that whenever we look at this normalization process, for years, no database administrator has ever been concerned about this zip code and this dependency between the city and state. Until recently, you started seeing websites where they guide you to the zip code first, and you type that in, and then it populates your city and state. You know then that that database is designed with the zip code as being a separate kind of key. So you can kind of tell how it works based on how the website interacts with you. On the Microsoft certification exam, they actually have some questions about normalization in the zip codes. So this is really, really good information for us in preparing for that exam. So no matter how we decide to store it, just the fact that we're realizing it's an issue for normalization, it's really important for us because we can handle it either way. But if we're Amazon and we think we're going to have, 5 billion addresses stored, should I have 5 billion zip codes stored, or should I only have every zip code stored, basically once in a control table that has pointers pointing to that? It's a really tough decision because the zip code's not a huge amount of data. So we're going to have that foreign key pointing to that zip code table that's going to be almost as much data as keeping the zip code itself. So it is something that's definitely up for debate. Okay, so scroll down for us a little bit. So there's what we're ending up with, that we have our doctor, appointment, and patient. So our final dependency is that city and state on the zip code. We can put those that dependency here on our diagram to show that that still exists, then we need to make that decision. Should we have a separate table that's like location, that has the zip code as a primary key, that has a city and state, and then have our zip code be a foreign key on this table, or should we just carry the address? We can have all sorts of arguments for either way. What are your thoughts? It'll mean more after we start doing some queries and you start seeing what kind of effort it takes to connect the two different types of entities when you're going through your database and looking at your information. So it can be handled either way. So if we're going to leave that dependency, let's go ahead and draw the arrows showing that we have the zip code that still has the city and state dependent upon it. And that's fine for us to leave it that way. In the instructor's material, they do mention that there are some zip codes that traverse states. So we could probably find some of those in the St. Louis area where they are in Illinois and Missouri both. So our design would have to get a little bit more involved if we were going to set up a separate zip code table or zip code entity. But just being aware of that and being aware of the fact that that zip code is an issue in normalization of addresses is just an important thing for us to think about. Beautiful. Let's save it and turn it in. You can turn it in as an Excel file, I think. Does it let you on Cengage? Because I don't.
Pretty sure it does.
Does it? Because I don't want you to have to fiddle with it in another format if it won't make you. Let's see what kind of messages we've got. Garrett, they made the arrows using the insert line tool.
I also figured out, I don't know if anybody else had this by list, but the online version of Excel does not have the same functionality as the desktop version. It's like a way pared down version of it. So like drawing lines and stuff doesn't work the same on the online version.
You have to do the full Excel.
The online version is free.
Well, you get the whole Microsoft Office suite free with your OTC account.
Yeah, but if you use the online version, it's the free version of Excel, which is going to be dumbed down either way.
Well, you have to log in through your OTC account. Like it's just like I ran into issues and I'm just going and logging in and downloading the app because the lines, for some reason, like it wasn't.
Right.
So a lot of this design that we've looked at, you guys have done a great job and we've used the tools that were available. And if you were working for a large company, they would have case tools, computer computer aided software engineering tools available to help you do some of these diagrams and things. So it might be areas that were real tedious, but it shouldn't be overall as tedious. But there are definitely some areas where when we're working with every data element, it can be a little tedious. But those are real small, you know, in between times of working on design. So when we go to do normalization, we want to make sure we have a complete list of all of our data elements. And we might, as our textbook mentioned, have to look at like an entity cluster, you know, pull out an entity cluster and all of its data elements to go through the normalization process to make sure we've identified any dependencies, eliminated any transitive dependencies where we have something that's dependent on something that is transferred off someplace else, and make sure that all of those kinds of things are taken into consideration in our design. Awesome. I'm gonna take over. Let's see. So everybody should have number 1 and number 3 for the module 6. I can't speak right. Module 6 problems ready to go, ready to submit. Go ahead and get those turned in. Let's do a real quick Quizlet live and then we'll switch to lab mode so for you guys to have some prep time.